Hello and welcome. This is Professor Adams, and we are going to do a quick video, it probably won't be quick, on multiplying and factoring binomials and quadratics. So we're going to refresh a little bit of skills here. We're going to talk about multiplication. Multiplication is commutative. What that means is if I write 3 multiplied by 2, this is 6. Or I can write this as 2 multiplied by 3. This also equals 6. So I can write 3 first, I can write 2 first, and we're good. I also know that they are associative. So if I did 3 multiplied by 2 multiplied by 4, this gives me 24 because I would do this multiplication first. I would do the 2 and multiplied by 4, which gives me 8. Multiply that by 3. Or I can write this as 3 multiplied by 2 multiplied by 4, and I'm still going to get 24. So again, I would do the multiplication of 2 multiplied by 3 and multiply that by 4. So I get 6 multiplied by 4 is 24. Okay, and that brings me to this, that I can write this as 3x minus 2, or I can write this as x minus 2 multiplied by 3. There's a reason why I'm doing this, so just hang on. So let's go ahead and do this first multiplication. Let's go ahead and multiply the 3 multiplied by the coefficient on x. Now remember, if there's no coefficient, or it looks like there's no coefficient on x, it's really 1. And you can put the 1 there. By convention, we don't. But it's okay if you do, and it's okay if you don't. So then we're going to multiply the 3 and that negative 2. And so I have 3 multiplied by that 1. So I have 3 and then multiply that by x. And then I have 3 multiplied by that negative 2. So I have negative 2 times positive 3, which gives me negative 6. All right. Now let's do a binomial multiplied by a binomial. Let's do x plus 5 multiplied by x minus 6. Now, I'm going to show you 3 different ways. They are all the same answer. We are doing the distributive property each way. You may just have seen it differently. So I'm going to multiply this x plus 5 onto the coefficient on x, and I'm going to multiply this x plus 5 onto the negative 6, just like I did the 3. So x plus 5 multiplied by 1x. And because multiplication is commutative, I'm going to write my x first. I'm going to write this as x multiplied by x plus 5. I'm going to multiply the x plus 5 and that negative 6. And again, I'm actually going to write my number first. I don't have to, but I like to, so I'm going to. So I have my negative 6, and it's going to be multiplied by x plus 5. Now I'm going to distribute, just like I did up here. I'm going to distribute that x onto the x and the x onto the 5. Now remember, when you are multiplying your variables, you are, with the like bases, you are adding your exponent. The rule is if you have a to the m multiplied by a to the n, you are adding your exponents. All right. And if you don't seem to see an exponent on these, just like the coefficient on x, when you don't see a 1 there, it's an implied 1. If you don't see a exponent or a power on your variables or even your numbers, it's an implied 1. So x multiplied by x is x squared. X multiplied by 5, the 5 is multiplied by the coefficient on that x. So I did the x multiplied by the x. I'm going to do the x multiplied by that positive 5, so I have plus 5x. Now I'm going to do the same thing over here. I'm going to distribute the negative 6 onto x. So I have negative 6x. I'm going to multiply the 6 and that positive 5. I have a positive 6, or excuse me, a negative 6 and a positive 5. I'm going to go ahead and write that. So I have minus 6 and multiplied by the positive 5. So we know that's going to be negative 30. So let's put a positive there, positive 5. There's a reason I'm doing that too, so just hang on, So we have x squared, and I'm going to combine up like terms. I know these two are like terms because they both have a variable of x. The exponent on both of those is 1, so I can add my coefficients because they are like terms. I have a positive 5 multiplied by a negative 6, and so I end up with negative That's not multiplied. Added, sorry. I have positive 5 added to a negative 6, so I have a negative x, or a negative 1x. And then I have minus 30. Okay? So that's the distributive property in all its glory, and it is delicious. So let's do it probably the way that you learned, which is the FOIL method, which is still the distributive property. But people remember the FOIL method. They have a harder time remember the distributive method, but it's the same thing. So we have x plus 5 multiplied by x minus 6. And I'm going to multiply my x and my x, and so I get x squared. I am going to multiply my x and my negative 6, positive 1x multiplied by a negative 6, so I get a negative 6x. And my first one was my fronts, so they call it the fronts. It is the first term in each of those binomial. It's the, quote, fronts. Then I did my first term here by my last term in my second one. They call that the outside, so that's the O in FOIL. Now I'm going to multiply my 5 and that 6. That's a positive 5 and a positive 1x, not 6. Positive 5 and a positive 1x, so I get positive 5x. That would be my I. We call those the inside. In other words, it is the second term in the first binomial, and it's the first term in the second binomial, and they call it the inside terms if you're doing the FOIL method. And then I'm going to do my last multiplication, which is 5 and that negative 6. So a positive 5 and a negative 6 is going to give me a negative 30. And let me see what color. I haven't used red. And we call those the last. So it is the second term in my first binomial and the second term in my second binomial. They call, quote, the last. So there's the FOIL method. Again, we know that these two are like terms, and we go ahead and add them, so we get x squared minus x minus 30. The last method. We're going to do the same one more time. You're like, oh, but Mrs. Adams, we have this. And I know. Just hang with me. It will be fine. Just hang with me. And so you might have learned it with the area method. We know the area of any rectangle. The area of any rectangle is the length times the height. Length times height. So we can do the same thing with our two binomials. I'm going to write this as x plus 5. And I'm going to write this as x and then minus 6. So this is the height. This is the length of this first rectangle. So we know it's x multiplied by x, which is x squared. We have this is my height and this is my length. So I know I'm multiplying x and my 5. So it's going to be 5x. And I know that this is my height, and then this, which is still this, is my length, and so I have negative 6x. And then my last one, this is my height, which is still my negative 6. You're thinking, but Mrs. Adams, we don't have negative measurements. I know that. It's okay. It's fine. And then my last one, of course, my length would be this 5. So this box would be the 30 right there. And it's negative because one's positive, one's negative. I would then have x squared plus 5x minus 6x minus 30. And I still am going to combine up like terms. And I have x squared minus x minus 30. All right. Now we are going to factor. So the great thing about factoring is you can always multiply it back through. You can always distribute back through and check whether or not you have the right answer. So we're going to start out with x squared minus x minus 6. All right. Now, the reason I started with a multiplication is one, to refresh multiplying through so that if you did factor and you wanted to check, you can remember how to do that. The other reason why I did that, because I wanted to show you what two numbers have to multiply together to get this constant term, or C. We are going to be looking at today quadratics, which means that it's a polynomial of power of 2, where we have x squared plus bx plus c, where c could be a negative number. It could be negative 6. So it'd be plus a negative 6 or just minus 6. And the important thing that we're going to be looking at is my coefficient right here is 1. So we're looking at when a is 1. It would have been ax squared plus bx plus c, but we're going to look at when the coefficient, or a, is 1. All right. Now, I'm going to go back up here. If we were to use the area method, that's this one. Let me highlight that. That is, that's this. This is the area method. If we were to use the area method, then we know, let me get in my pen, not my highlighter, so just give me a minute. Let me get rid of that, my pen. So we could do our box, just like we did with the area method. And we know that negative 6 has to go right there. We know that x squared has to go right there. And we know that whatever's in this box and whatever's in this box, these two have to add up to this coefficient right there, which we know is 1. So we know that there's going to be an x here and an x here, because we know that this multiplied by this has to fill that box. And we know whatever's going to go right here, let me put in the same color as I had up above. So let me scroll up really fast. It was yellow. So we know to fill this box right here that this number and this number have to multiply together to get me that negative 6. And it's green and blue. I should have done that the other color. Anyways, so we know that this times that, so some number here, again, some number right here, multiplied by x needs to go in this box. And we know that some number here, multiplied by x, needs to go into that box. But we also know that those two numbers multiplied together needs to be negative 6. So the first thing you do is list out your factors of 6. Not negative, just 6. And we'll talk about the negative in a minute. So I'm going to list out my factors of 6. So I can get to 6 with 1 multiplied by 6. And I can get to 6 with 2 multiplied by 3. Now, what I know is that it is a negative. This is important, a negative 6. Right here, this is a negative 6. That tells me that 1 has to be positive and 1 has to be negative on my factors of 6. Because, this is just a quick little fresher, if I have a positive 3 and a positive 5, then I'm going to get a positive 15. But if I have a negative 3 multiplied by a positive 5, I'm going to get negative 15. Or if I have a positive 3 multiplied by a negative 5, I'm going to get a negative 15. So in other words, one's positive, one's negative, and we're going to get a negative answer when we multiply. Okay, so coming back over here, just quickly come back over here, and here we are. So my two factors of 6 have to be positive and negative, and they have to add up to negative 1, that negative 1 right there. So if I come over here, I have a positive, if I decided I'm going to do positive 1 plus a negative 6, or I can write this as 1 minus 6, this is not going to give me a negative 1. And if I had a negative 1 plus 6, that also is not going to give me a negative 1. So I'm done with those. Done with those. Done. Okay? But if I have a negative 2 plus 3, this is going to give me, positive 1. Not quite, but at least I'm getting 1. Still not negative 1. If I have a positive 2 and then plus a negative 3 or 2 minus 3, I'm going to get my negative 1. So here it is. That means these factors are positive 2 and that's a negative 3. So negative 3, negative 3. So I know this is going to be negative 3 and I know this is going to be positive 2 because in this box, this is negative 3 times x, and in this box, it's going to be a positive 2 times x. And these two are going to add together, and we know that's going to be a negative x. So that's with the box method. You can see it that way. what I do, and I start out usually with box method, is I just jump right in. I have x. Oops, I want to start out with my original one here, so let me start out with my x squared minus x minus 6. I assume right out of the gate this is going to factor. So I have x and I have x. The only way I can get to x squared is x multiplied by x. And since my coefficient right here is 1, the coefficients in here is 1. You don't have to write that. I know the factors of 6 are 1 and 6, 2 and 3. We know that. We also know because of this sign, they have to have opposite signs. And the only way I can get a -1 right there is if it is a -3 plus 2. And you're going to say, but Mrs. Adams, is it okay if I would have wrote this as x plus 2 first and x minus 3? I'm going to say yes, because multiplication is associative and commutative. So because we are having two factors, x plus 2 and x minus 3, they are commutative, so I can write it as x minus 3 first or x plus 2 first. Let's do one more on this page. So let's do x squared plus 7x plus 12. All right, so I know I'm going to assume this thing factors x and x. Now, I look here. That's a plus. So I'm going to look for the factors of 12 and I'm going to list them out. 1 multiplied by 12, and I have 2 multiplied by 6, and I have 3 multiplied by 4. And the only way I can get a positive there, the only way I can get a positive 12 is if I have a positive 1 and a positive 12, or I have to have a -1 and a -12, because a negative multiplied by a negative is positive. So that means a positive 2 and a positive 6, or a -2 and a -6. Then I have either positive 3 and positive 4, or I have a -3 and a -4. Now, I know these factors of 12 have to add up to this b, and so it's 7. And because this sign is plus, they're both going to have the same sign, and they're both going to be plus. So I know it has to be these two, because 1 plus 12 is not 7, 2 plus 6 is not 7, but 3 plus 4 is 7. So I have plus 3 and plus 4. And again, I can always check these by doing the distributive property. So I can multiply the x multiplied by the x, so I get x squared, and I multiply the x and that positive 4, so I have positive 4x, and the 3 and the x, so plus 3x, and the 3 and the 4, so plus 12. And look, here are my factors of 12 that have to add up to 7x. So x squared plus 7x plus 12, 12, and so we know we have the right answer. Another example that we're going to look at is x squared minus x minus 6. Oh, actually, you know what? Let's make that plus x minus 6. So the first thing I'm going to do is I'm going to assume it's going to factor. Leading coefficient's 1, so we're good to go. I don't have to worry about any greatest common factor first. It's just x squared plus x plus minus 6. So the first thing I'm going to do is I'm going to assume it's going to factor, so I'm going to go ahead and write my parentheses. And I also know that the first term in each one of these factors, these binomials, have to be x, because the only way I can get to x squared is if I multiply x by x. Now the next thing I'm going to do is I'm going to look right here. I'm going to look, that is a -6. So I'm going to list out the factors of 6. I have 1 multiplied by 6, 2 multiplied by 3. Those two, when I multiply them together, give me 6. But my options are a -2 multiplied by a +3, or I have a +2 multiplied by a -3. And the same thing with the 6 and 1. I have a -1 and a +6, or I have a +1 multiplied by a -6. Okay, so it's one of these groupings. One's going to be positive of the two factors of 6, and one's going to be negative on the two factors of 6. It's just the way it has to be. Now I'm going to look to see this right here. Now, when I'm talking about ax, so it's ax squared plus bx plus c, where my leading coefficient or my a value is 1. I know that these factors of 6, by my multiplication, these factors of 6 need to add up to 1 as a coefficient on x, and not only 1, but positive 1. So if I were to add the two factors, so negative 1 plus 6, this does not give me a positive 1. A positive 1 minus 6, or plus a negative 6, does not give me a positive 1. So I know that those are out. So I know that's not that one, it's not that one. I have negative 2 plus 3 gives me a positive 1. Oh, there it is. So that means when I come over here, these are my factors, I'm going to write this as x minus 2 and x plus 3, because I know when I go to distribute this, and I can check these. That's a great thing about these, is you can always check them. You can multiply it through. Whether you're doing the FOIL method or the distributive method, it is the same thing. It's just called the FOIL method. You can check these. So you can multiply this through. X times x is x squared. X times positive 3 is positive 3x. 2 times that x, the negative 2 times that x, is a negative 2x. The negative 2 times that positive 3 is a negative 6. And you can see these are the factors of negative 6 that will add up to our middle term, which happens to be positive x. So I have x squared plus x minus 6. Now, let's do another one. Let's do x squared minus 5x plus 4. So the first thing I'm going to do is I'm going to assume it's going to factor. So I'm going to write my parentheses. I'm going to write my x here and my x here, because again, the only way I can get to x squared is when I multiply the two x's. And I'm going to list out the factors of 4. My factors of 4 are 1 and 4, and 2 and 2. So I'm going to go look right here. This says it's plus 4. That means the only way I can get to plus is that they are both the same sign. So a positive 1 multiplied by a positive 4 gives me a positive 4. A positive 2 multiplied by a positive 2 gives me a positive 4. Or it is a negative 1 multiplied by a negative 4, which gives me a positive 4. And a negative 2 multiplied by a negative 2 gives me a positive 4. Because the double negatives when I multiply is positive. Now, I'm going to look at this sign and this value. I need factors of 4 that add up to a negative 5. So if I had the factors as a positive 1 and a positive 4, they are not going to add up to a negative 5. A positive 2 and a positive 2 do not add up to a negative 5. However, if I were to write this as negative 1 multiplied by negative 4, so negative 1 multiplied by negative 4, give me that positive 4, and negative 1 plus that negative 4, or in other words, negative 1 minus 4, that does give me my negative 5. So I know what my factors are. It is going to be negative 1 and negative 4. You can always check these. Let's give you one more example. So I have x, oh wait, let me erase that parenthesis because I want it unfactored. So let me erase that parenthesis. So I want unfactored. I have x squared plus 7x plus 15. So I'm going to assume it factors. I'm going to go ahead and write my parentheses down there. I'm going to assume the x, and there's an x. And so I'm going to then list out the factors of 15. So 1 times 15 and 3 multiplied by 5. Or, again, this is a plus. So either I have positive 1 and positive 15, or I have a negative 1 and a negative 15. I have a positive 3 and a positive 5, or a negative 1 and a negative 5. They have to be the same signs. I'm going to go over here, and this is a plus as well. So that means my factors have to add up to a positive, and it has to be 7. Well, okay, so that means my factors both have to be positive. So 1 plus 15 does not give me 7. 3 plus 5 also does not give me 7. So what that means for me is that I have a polynomial. I might be able to throw in a quadratic, might be able to complete the square. I may get real answers or I may not get real answers. But what I do know is this will not factor over the integers. So when you're doing the factoring, when your leading coefficient, let me wrap this up. When you are looking at a polynomial, a quadratic, where it is x squared plus bx plus c, we know that we are looking for the factors of c. So in other words, the two numbers that multiply together to give me c that have to add up to my b value. And it's going to tell me whether or not they're both the same sign right here, or if they're both, or if they are opposite signs. So the only way I can get a negative right here is if one of my factors was positive and one of my factors was negative. So thank you for watching. Please leave comments, and if this helps, great. And if it doesn't help, that's okay too. And any constructive comments, gladly welcome. Thank you again for watching.